All right, thank you, guys, and welcome back from the lunch. So we've got two security sessions back to back, so we've got some exciting demos to show you as well. So the first one, we'll get started with the topic on understanding the AWS Cloud HSM and the AWS Web Application Firewall. So what we are going to cover in this session today is understand the new Cloud HSM offering that AWS has launched just recently, and how is Cloud HSM really helping the customers to put restricted and highly sensitive workloads into the cloud, right? So we'll cover the functions, the features, we'll look at the architecture, we've got a demo to show on the deployment side of the HSM as well. And following that, I will talk about the AWS Web Application Firewall on how the WAF can help you protect your web-based infrastructure from advanced security attacks when we look at cross-site scripting, SQL injection, and also providing protection for your infrastructure from distributed denial of service attacks. So with that, let's get started. So when we talk about running restricted workloads in the cloud, as much as it's about security, it's more about the control, right? And when we talk about control, one of the key concerns that we see from the customers is that I want to have control of my master keys, right? I do not want even AWS to have the control of the master key. Now, this is where the Cloud HSM comes into the picture, where it provides you a hardened appliance which can store your keys and only you have the access to it, right? And the other key requirement is around compliance. Now, the HSM needs to be compliant to the FIPS 140 level 2, level 3 and above, and also the common criteria. And the last one is around performance and availability. Now, when you're hosting workloads in the cloud and you're using a HSM in order to do your key storage and encryption and cryptographic function, you want your HSM to be housed within the cloud, not on-premise in a hybrid environment due to the performance and the availability side. So, to put things into context, we'll start with data classification, because when we look at moving workloads in the cloud, one of the key requirements is that you need to classify your data. So I've got a simplistic view of a data center over here, which essentially talks about how you can have a different type of data stored in your typical data center, right? You will have unclassified data, you will have secret, top secret data, depending on what the requirements are. So in order for you to understand what workloads can move onto the cloud, the classification of that is really important. And what is also important to understand, what is the impact of loss? So if you've got some sensitive data, business critical data that is being hosted in the cloud, you need to understand the loss of impact for that. And then further, understand what are the external requirements or internal compliance requirements that data needs to meet. So your entire data classification then drives your overall requirements on you deciding on what is going to move to the cloud. So if you decide moving, as I have in the example, moving your unclassified or your restricted workloads in the cloud, the next aspect is to see how you can apply security controls, right? We need to apply things like data encryption. We need to then look at how we're going to do the key storage. And depending on what your environment setup is like, if you're using Oracle, MS SQL databases, and you want to enable transparent data encryption, which can directly integrate with the HSMs, on how you're going to do that. So key requirements, very much driven through your data classification requirements to understand on how and what you're going to move into the cloud and what security controls you're going to implement. So this brings us to the Cloud HSM service offering. So we launched the new Cloud HSM service in August this year, and it is a similar appliance on what a Cloud HSM is or a HSM is supposed to do. It is a hardened appliance. It's tamper evident. That means you cannot physically tamper or logically tamper the device. It provides the same function with regards to a strong key storage onto the appliance. It provides you with the encryption and the cryptographic functions that it supports. So the predecessor to this Cloud HSM is what we had was a Cloud HSM offering, which was using the SafeNet and the Gemalto appliance, right? So it was a physical appliance which was housed in the AWS data center, which was being used, right? So that has now been replaced by the new Cloud HSM service, and the previous Cloud HSM service is called the Cloud HSM Classic. So let's look at some of the differences between why we moved to a new service, what are the key advantages you as a customer get out of it. So one of the biggest requirements from a Cloud HSM aspect we were asked from our customers is that if I'm going to be moving my restricted workloads in the cloud, it needs to be FIPS 140 level 3 compliant. So the new Cloud HSM is a level 3 compliant appliance. The classic continues to be level 2. The other one is around pay-as-you-go model, right? In the classic version, if you were to go through with the Gemalto SafeNet appliance, you have to pay $5,000 upfront, and then there is ongoing cost as well. So now that aspect has been removed. The other key requirement was high availability. So high availability in the new Cloud HSM service is ingrained into the entire setup. Now I'll talk more about the architecture on how HA is done and what it offers to you in the later slides and when we discuss the architecture. And in the classic version, if you were to achieve HA, you really had to configure another appliance, make sure the cloning is done. It's a pretty tedious and a manual task in order to achieve that. The other big requirement was from a user experience perspective, right? In the classic, we had only CLI-based access. The only way you could configure the HSMs was to access it through the CLI and then go through multiple steps in order to configure it. Not a good user experience. So the new version comes with a console, so you can log into the web-based console, and then you can configure and create your clusters and your HSMs. And again, I'll walk you through that when we do the demo. And the last one is the quorum-based authentication. So one of the key reasons for it to be now level 3 compliant now is because you can do quorum-based authentication. So what does that mean is, if you have a very critical workload running in the cloud and you want to ensure that there are multiple parties who need to sign in order to approve a certain action, the quorum-based authentication then supports using a secure ID. You can take a piece of secret, break it into 3 or 4 pieces, depending on how many people you want to authorize that. And then it uses 2-factor authentication where all 4 people need to give the consent before an action can be taken. So compared to the classic version that could not be achieved in a cloud environment because the SafeNet appliance requires a pin entry device which you physically need to plug in, which again, in a cloud environment, it's not something feasible. All right, so before I get into the features and the functions and start talking about the architecture, I really want to talk about the user experience. I mentioned that one of the key requirements was to give a good user experience. So if anyone has experience configuring a HSM, a SafeNet, Gemalto, Thales HSM, you would know that it takes weeks to configure that. And what we have been able to do now with the new Cloud HSM is the experience is good enough that we can install it with a single API call, and it takes about under 15 minutes to install. So yeah, so how good is that? So I'm going to have my assistant Alexa who will help us deploy this environment, and I'll just run you through the setup. So just bear with me, and I'll try not to swap between the screens too much to make you dizzy. So this is the console that is there, right? So it's the Cloud HSM console. So what you get when you start with is a blank screen. Essentially, we don't have anything configured. And what we're going to now do is get Alexa to essentially install that for us, right? Alexa, open Cloud HSM console.
I'm not quite sure how to help you with that.
No, sorry about that. Alexa, open Cloud HSM.
I'm not quite sure how to help you with that.
Sorry about that. Let me make sure I'm connected. So I did practice this before. All right, I think I may have lost the connection. All right. Sorry. All right, let's give it a try again. Alexa, open Cloud HSM console.
Now connected to AWS Management Console. Please specify a region.
Connect to North Virginia.
Successfully connected to North Virginia.
Deploy Cloud HSM.
Deployed new Cloud HSM stack.
All right, so what Alexa has now done with a single API call, we are not going to deploy the entire HSM setup. So I'll just walk through the architecture and let it do in the background what it is doing, and then we'll keep a track of how the installation is going on, right? So So when we create the new architecture, the way it is deployed is you select a region, and within the region, you have multiple availability zones. So in our example, we have North Virginia with 2 availability zones, and it is now creating a VPC, which is going to span across the 2 availability zones. It is also then going to build subnets in each of those availability zones. So there's going to be a public subnet, and there's going to be a private subnet. So the public subnet will have the HSM client, which essentially is an EC2 instance, which has the CLI running, and it has the certificates that's installed on it. And you can only connect to the HSM via the client. So it's a secure connection, and it's established as an end-to-end encrypted channel between the HSM and the client. So once it has deployed that aspect, it will then create a cluster. Now, when we talk about high availability, so what the deployment is now doing is essentially creating a cluster across the 2 availability zones, which let you add the HSMs into the cluster. So what that will do is that in a single region, you can have anywhere from 1 to 32 HSMs installed. And each of them are part of the cluster, so you get high availability built into it. So if one HSM fails, the other one just takes over. So let's have a look at how our deployment is going. So I'll just go to the CloudFormation. So what the API call has done is just called a CloudFormation template, which is, so I'll select North Virginia. So you can see that the Cloud HSM script has now run, and it is now installing. So the first thing, as I said, it would have installed is a VPC. So we'll have a look at our VPC. It should have 2 VPCs and subnets created. Oops, I'm sorry. Nope, it's not swapping for some reason. So, guys, can you have a look at it, why it's not swapping? All right, something wrong with the display, guys. My apologies on that, but I just want to show you the console. All right, cool. Sorry about that. So, all right, so you can see that we got the test environment, which is the VPC that has been created. So I'll just give you a dashboard view, which is much better. So 2 VPCs, the subnet groups, the subnets have been created. And the next step that it is doing is installing the EC2 instance. Now, EC2 instance gets installed. Now, there are a fair amount of configuration that happens. Now, again, if you're coming from a hardware-based or even the Cloud HSM SafeNet-based installation, you have to create the certificates, you have to do OpenSSL, and then once the certificate is created, you upload the certificate onto the instances. So there's a fair amount of manual processing that needs to be done that is now fully automated. And what we then see is, I'll just jump onto the EC2, so we'll see if the instance has been created. All right, so we got one running instance. So it has provisioned, so the instance, and the next step that it will do is essentially create a cluster. Now, it takes a while to create the cluster because there are configurations that happen at the network layer, and then adding the HSM, which then takes time to initialize, and then it moves its state to active, and it performs a lot of functions, which typically take anywhere from 4 to 5 minutes for it to be done. So what I'm going to do, I'm just going to swap back to our slide, and I'm just going to talk about some of the features of the new Cloud HSM. So fully managed clusters, right? So that's what I was talking about. So you have these clusters that are created across your availability zones. You add your HSMs onto it, and then it basically gives you a fully high available environment. Managed backups. So we are now automatically taking encrypted backups for your HSMs. So you can then restore point in time. So if you want to scale down and turn off all your HSMs, you can then restore from the backup and then spin up a hardware security module right from the backup. Automated replacements, so unhealthy HSMs are replaced with the healthy ones if there is a failure. It's less expensive, right? So not only there has been the upfront cost that has been removed, the ongoing cost has been reduced by more than 35%, so it's much more affordable to run a HSM. Larger key storage. So one of the key requirements from our customers has been we wanted hardware security modules which have a larger space size. So there's 100% improvement on it from the predecessor. So now you can have up to 3,500 keys that can be stored on a single HSM. So if you go up to adding 32 HSMs, you have more than 100,000 plus keys that can be stored. And on top of that, you can have 1,024 unique users who can then manage their individual keys onto the appliance. So it really has scaled even for the largest of the environments on what you can now achieve with the new setup. It's more secure. Of course, it's got the level 3 compliance now, and you can do the quorum-based authentication. There is 2FA enabled on it. And it is standards compliant, right? So it is now compliant to open standard, JCE, and other open standard, the PKCS 11. So if you're building applications that will be using the HSM, it is much more portable, and you can move from the HSM or off the environment if you want to. So it makes the things much, much easier. So we'll just swap back quickly and see how the HSM installation is going. So we'll go to the Cloud HSM setup. It should have created our clusters now. All right, so the cluster is created. As you can, is it again gone? So, jeez, sorry. All right, thank you. So we have the clusters created. So it's create in progress, so it will then change its state to uninitialized. So once it is uninitialized, it will then start adding HSMs to it. So again, the whole process takes about 15 minutes, and the deployment is done. So if you were to compare how it was being done in the past, taking 2 weeks, reduced down to 15 minutes, is really what we see value from a cloud-based offering, right? This has been an ask from our customers saying, we want the service from Cloud HSM, which is the Amazon way, right? It needs to be automated. It needs to be deployed in time. When we need, it should not have 2 weeks lag to install and have all the manual tasks associated with it. So just making the entire process much, much easier. So, all right, so we can see it is now initialized, and it has added a HSM to it as well. So that completes our installation, right? So now you have a HSM, and then it will, and you can keep adding more HSMs to it depending on what your requirement is. All right, so let's look at some of the key use cases, right? So one of the things that you can now do with the HSM is that you can do your TLS offloading. So in the environment, in your cloud environment, you can do TLS offloading at the cloud front. You can do it at the Elastic Load Balancer, or you can do it at the EC2 instance level. And now you have a fourth option that if you want to do offloading of TLS sessions, you can even do at the HSM. The second use case is around you can set up the Cloud HSM as a certificate authority. So essentially, you can use it to issue certificates for your organization. And if you're using databases which are hosting critical data, and you want encryption of that to be done, and you want the key storage to be done via Cloud HSM, there is a direct integration using the transparent data encryption, and there is no software in between required. So you can simply connect your Oracle database with the HSM and have TDE enabled. All right, moving on to the web application firewall, right? So one of the requirements, when you're building and exposing your environment to the internet is to ensure that you are providing it protection from web-based attacks. Now, WAF comes into view when you are looking at providing protection to your web-based applications. So the web application firewall can integrate at 2 different points. You can integrate it with your cloud front, right at the beginning, and that's what is there in the architecture, or you can even have the WAF integrated at your application load balancer. Now, depending on your use case, you do have the 2 options on how you want to do the integration. So what comes with the WAF is, again, it's a single-click install. So you can install, and I will show you in the demo, the entire web application firewall, which has pre-built rules for the OWASP top 10. So all the top 10 rules for protection against cross-site scripting, SQL injection are built into the web application firewall. The other thing you can do with the WAF is to use Lambda, and what Lambda is doing in this architecture is Lambda is integrating with two different parts. One, it is talking to a third-party IP reputation provider, and it is continuously polling it, or you can configure the polling to be done on an hourly basis or however frequently you need to do it, and it will get the updated IP reputation database from the third party. The other thing Lambda is doing, it is also looking at the access logs that are stored in S3. So whenever there is traffic coming in and it is hitting a web application firewall, the logs are stored in S3, and Lambda is looking at those logs, and what it is in particular looking at is the requests which are bad requests. So if you see that there is a request coming from a certain IP address which goes as 403 forbidden, and you're getting too many of those requests, what Lambda will then do, it will add that IP address as the source to its blacklist, and it will then stop any further sessions or requests coming from that IP. So it then provides you the protection from an IP perspective, right? Talking more on the advanced side on what you can do with the web application firewall is to apply virtual patches. So think of a scenario where you have a web-based application. It could be developed in-house, or you could have a third party that would have developed the application, and you find a vulnerability in that application. Now, there are always going to be some time before you have a patch that is available. There could be a dependency on your third-party vendor. There could be time that your internal development team is going to take to test and to deploy that particular patch. But during that time, you want to ensure that your environment is secure. So what you can do at the WAF, you can create custom rules. So when you are aware of the vulnerability and you don't have the patch, but you understand on how the vulnerability can be exploited, you can create the custom header size, the URI location, what is the cookie size, and create those filters and apply those filters onto the WAF. Now, what that lets you do, it basically creates a virtual patch for you. So for the time that you do not have a patch applied to the application, you have an appliance sitting at the network level, looking at the traffic which is trying to exploit the application, and protecting it and stopping that attack because it's matching that criteria. So that's one of the use cases on how you can apply the web application firewall. So the second aspect is providing protection from distributed denial of service, right? Again, one of the key things, and it's one of the blind attacks, right? We need to provide protection against the DDoS attacks, and in particular, we are seeing the rise of more and more application-specific DDoS attacks, and this is where the WAF again provides a lot of help with regards to detecting and then mitigating those attacks. So the architecture for DDoS protection is what we have is a defense in depth architecture. So if you look at the architecture with regards to the first thing that we have is Route 53. So Route 53 is our highly scalable, redundant, dual home DNS service, and it provides you with traffic management, right? So you can configure on how you want to manage the traffic coming in, whether you want to do latency-based traffic management. So Route 53 can route traffic between your availability zones based on which is the fastest path. Or you can do weighted based, right? So you can say, all right, I want to have 30% going to availability zone A, I want the 70% going to availability zone B. So during a DDoS attack, you can then do the traffic management accordingly, and you can manage those controls from Route 53. The second layer of defense is CloudFront. So CloudFront helps you apply geolocation rules. So during your planning process, when you are deploying a DDoS mitigation solution, you can look at the countries that you do not operate in, or you can create a list of countries that you consider unsafe. Or during a DDoS attack, if you see that the attack is originating from a certain country, you can apply those rules and block the traffic coming from that. The web application firewall helps you detect the attacks from a perspective that it is looking at all the traffic coming in, and it can give you a profile and a pattern of what kind of traffic is coming in. And then you can build custom rules to ensure that that particular traffic is blocked, right? What application it is targeting, what port it is targeting, what kind of packet size that is coming through, and the multiple variables that you can do in a packet capture, you can see through that. So, combining with WAF is also AWS Shield Advanced Service, which is our DDoS service. So when you subscribe to that advanced service from AWS, what you also get on top of the web application firewall is a 24/7 DDoS response team, which can help you in different stages. It can help you during your planning stage when you're deploying your WAF. It can also help you during an attack to come up with the firewall rules that you can implement and you can mitigate the attack. And it can then help you after the attack so that you can run, you can do a postmortem and do a root cause analysis of what really went wrong. So the layer after that we have is where you have your elastic load balancer, your EC2 instances, and your virtual firewalls, which are part of your load balancing, part of your auto-scaling group. So typically what happens is during a DDoS attack, you will have 30 minutes or more when you are trying to figure out where the traffic is originating, what is the pattern, and your environment will take a hit. So at this point in time, you need to ensure the availability of your environment. So auto-scaling will scale out, and it will increase the number of instances and load balancers. And if you have a flexible firewall licensing policies, you can even have your IPS scale accordingly. And one of the key features, again, if you are subscribed to the AWS Shield, is that you get cost protection. So when your instances end up multiplying and you are subscribed to the AWS Shield Advanced, we essentially do not charge you for the time that you were under attack and the instances multiplied, right? So that really provides you with a comprehensive defense in depth, where every layer provides a complementary solution and mitigation strategy to the next layer, rather than creating a redundant set of controls, and provide you the security against your providing you security for your web-based applications. All right, so I think I'm probably over time, or can I? I'll just wrap it up. I had the demo to show for the WAF, which essentially I can just talk about it. We have a CloudFormation template that's available. So it's very much a single API call, and it deploys the entire WAF, and it also implements the OWASP top 10 rules for you, and it takes under 3 minutes to have a WAF implemented, right? So if you have experience deploying a WAF in the past, it is a lot of hard work to be done, but it's really as much as a single API call to install it in the cloud environment for you. So with that, I think the session is done. So thank you very much. And
thank you, Ankush.